Just give it a sec for it to catch up.
Yeah, give it a second for the stream to pick up. I'll tell you when we are good, but it looks like probably about 5 seconds, or I might just be talking to people who are watching right now
Yep.
and they're dealing with it. Yeah, we're live.
Nice. Well, welcome everybody to the SLC.net user group for January. So tonight we'll be able to hear from Mike Clement on Taming Scary Production Code. So with that, looks like we didn't add all of your bio here. See, I think I am, if I go to non-full screen and go to slcnet.tech here, can you see my screen? I'm hoping you can.
Yeah.
Okay, so just so we can see a nice picture of Mike right here. Okay, so Mike's husband, father, if you don't know him, then you probably weren't around a while ago. So Mike is, I don't know if he's a native of Utah, but he was in Utah and you either led or co-hosted or something the not the SLC.net, the Software Craftsmanship Group. Is that correct?
That is correct. I was one of the founders and co-organizers for about 5 years.
Yep. So Mike has done lots of great work. We've seen, well, at least some of us have seen many of his presentations. He is truly a software craftsman with a lot of experience across different domains in training and teaching and everything. So I don't need to say much more than I expect we'll have a great time learning from Mike. He's currently working remote, but for immersion learning here out of Utah. So with that, let's just go ahead and hand the time over to you. Let me check to see if there's anything else on housekeeping. And I have lots of tools covering my different windows. So I can't see everything I'd like to. Okay. Okay, so all of that will come after. So with that, we do have this streaming to YouTube. So if you happen to be watching on YouTube, we are going to try to pay attention to the comments. So know that you can add comments to the YouTube channel. One of us here will ask those questions to Mike so that he doesn't have to try and follow along while also working in his IDE. And with that, let's just go ahead and jump in. So Mike, you should be able to go ahead and take over a screen share and we'll get started.
I will make Mike the person presenting. Hang on.
Okay.
Awesome. Thanks, Caleb. Okay, so tonight we're going to be talking about taming scary production code that nobody wants to touch. If you'd like to participate, and I'd appreciate your participation, if you go to slido.com and use the event code 7270, or you can use the nifty little QR code that's up in the corner, you're welcome to do that. Just going to ask a question, and then also, in addition to all the other ways that you could potentially ask a question, you could also ask questions via Slido, and that way I'll go through them at the end of the presentation. Okay, so when I originally pitched this topic to multiple different conferences, I actually pitched it with the title Modernizing Legacy Code. And I submitted it to several conferences and nobody accepted it with that title. And so that's why I went ahead and renamed it Taming Scary Production Code That Nobody Wants to Touch. Part of the problem is that there is significant, I don't know if confusion is the right word, but difference of opinion with regards to legacy code. So again, if you haven't joined, I'm going to ask a question here in a second and enable that. So no matter which platform you're on, the question is, how do you define legacy code? Really, like, what is legacy code? And I will give everybody a minute to enter in their answers into the Slido. Again, I'll go back to this and you can go ahead and get in there, and the poll is now active. And I'll share those results in a second after we've gotten a couple results in. Okay, we're starting to get some in. So we have, starting at the bottom, we have code without unit tests. We have code I wrote yesterday, something I wrote last week, code that has been around for a long time and is not up to the current coding standards of today. Another one about tests. Nobody in the company was around when it was developed. Existing code written by predecessors. Outdated technology, not actively maintained, right? Difficult to modify. All these are great answers and kind of represent the variety of ways that people think about legacy code. Now, notice that, well, so most of these are not particularly happy things, generally. If we pull up a couple definitions, as many people said, right, legacy code is often code that we've gotten from somebody else. This is probably, like, in terms of like a definition, probably most accurate in terms of like the word legacy, right? Legacy is often something that somebody leaves behind. But, you know, that's not always how we think about it. As some people said, right? Legacy code is code that we've gotten from past self. It's code that I wrote recently. It's maybe code that I wrote last week, 5 minutes ago, whatever. But it's, you know, in addition to somebody else, like, it's maybe past self that gave it to us. Wikipedia defines it as a slang term for difficult to change code that we don't understand, which kind of goes to this whole idea that when we say legacy code, we maybe could define it as like code that somebody else had, but really we just use it sometimes as like legacy code is code we don't like. Now, Michael Feathers, in his book, Working Effectively with Legacy Code, he defines it as simply code without tests, which several of you picked up on, right? This idea of code without tests can be difficult. Now, I had the opportunity to talk with Michael Feathers, I don't know, a couple years ago, and asked him, you know, now that the book has been out for, you know, over a decade, would you define legacy code differently than you did in the book? And so, interestingly enough, he did. He said, well, first he said, as a consultant, I define legacy code however I need to in order to effectuate the change that I need to see, I want to see in the organization that I'm consulting with. So, you know, the definition is obviously flexible, but the one he said that he was thinking about at the moment was this, that when the people turn over faster than the code. And this kind of goes to that idea that, like, when the code was not written by the people who are currently working on it, this can cause some problems. For the purposes of tonight, and for the purposes of how I structured this presentation originally, was that legacy code is code without tests. And Michael Feathers makes the further assertion in Working Effectively with Legacy Code that code without tests is bad code. And so I asked the question, is that true? Is code without tests bad code? And then I think, what even is bad code? Now, bad code is a little bit subjective, and this next statement will also be subjective. But for me, code without tests is scary code, right? and therefore legacy code or code without tests is scary production code that nobody wants to touch. I think we've all been in situations where we've been in, walked into situations in either within our company or moving to a new company where there's a bunch of code that you encounter. And when you go to look at it, you take back the covers, it feels like this, right? Like you're not even sure which of these switches is active. You notice that there's, maybe there's some live electricity behind the little plates where switches, the actual switch part is gone. Some of these may be wired up, some of these aren't wired up. We don't know. And so it's very difficult to make any changes. And the temptation that we feel, because it is code written by somebody else, and therefore we maybe have we definitely have less of an understanding than the person who wrote it. Because of that, we feel the need occasionally to just rip it all apart and build it again. In the small, sometimes that can work, but in the large, that leads to a host of other problems, which we're not really going to talk about tonight, because this whole thing has to do with risk. So when one company I worked for, they're in Utah, which will remain nameless, there was one particular function method in this code base. It was a system that part of it did payroll. And in the payroll section of the code, there was essentially one large method called do payroll checks. And did it ever do payroll checks? Like that, I mean, it was a multi-hundred line function. It had originally been written in VB6 and been ported to VB.NET by ported, I mean copied and pasted and fixed the compilation problems, I guess, or weird, like the quirks between VB6 and VB.NET, and then had been continued to be iterated on. And in this case, there was really one person that knew that code. And that caused certain problems, right? If that person was out and somebody else had to go into it, right? We end up feeling like I have to go out and I have to take a bunch of risk in order to make a change. So, if I were needing to make a change in that code, right, in order to mitigate the risk as we're changing code, we want to think about these three things, right? One, be very targeted about what changes we have to make, right? Be very clear on that so that we don't change more than we need to. Second, and that's usually something that we have a lot of experience doing. We have a lot of experience interviewing users, figuring out what it is that we need to change, reading the code, possibly knowing where in the code, which module we need to change, which component we need to change, whatever it is, and hopefully which class and which method. Number two, though, is how will we know when we've done them correctly? Now, oftentimes what we do when it's pretty easy that because we've defined what it is that we want to see change, it's pretty easy to see, okay, I made this change to the code. Now that change is happening, right? Problem is often number three. Like the change that we wanted to make happened, but how will we know when we haven't broken anything, right? When we're dealing with code we're not familiar with, oftentimes what happens is we make a change, but then that cascades into other things. A friend of mine talked about an experience where there was a method that it did a database activity and then it closed the connection and is like, oh, well, this method doesn't say that it closes the connection. Where does it open the connection? And so he changed it. That ended up causing all sorts of problems, and they were hard to detect until Oftentimes they're hard to detect. Those types of changes are hard to detect until they're in production. So how will we know that we haven't broken anything, right? The additional thing is that this code that is clunky and hard to work with, we're less likely to change it. And so it kind of reinforces this behavior of, well, you know, that code is hard to change and therefore I'm not going to make changes in it, which then kind of ossifies the hardness of it to change. Uncle Bob posits this question, and I'm going to I'm going to have a Slido poll here up in a second. But think about your answer to this. Like, is it more important for the software to work? Or is it more important for it to be easy to change? And I am going to... So you should, if you're still in Slido, you should be able to get a poll that will allow you to select between the two, whether it's more important to be easy to change or more important to work. Give you all a couple of seconds to, so I see Eric asking, it depends. Of course it depends. This is like a thought experiment. Don't take this too seriously. But like, again, if it was really hard to change and it worked, or would you rather have it like not working, but be easier to change? So, okay, we have about 13.
Can you put up the QR code again for a second?
Oh, sure, I can do that. So if anybody else wants to join that wasn't able, or that lost it or would like to, go ahead. Sorry about that. This is my first time using Slido for this presentation, so I don't really have it like super smooth in here. Sorry. Okay, so now we have that. Hold on. Okay, so again, this is a thought experiment. It is not real world. It is not something that you'd ever really get, right? You're never really going to get to decide this. But let's go ahead and see what people said. So interesting. More people said it's more important to work than more important to be easy to change. Now, again, it's a thought experiment, so there's no like right answer per se. But in this thought experiment, looks like we're easy to change is starting to catch up. But this is what Uncle Bob says in his book, Clean Architecture. The thing is that, right, in this world, potentially, and again, this is another stipulation that maybe wasn't specified when you're choosing which one. And just so you guys know, it flipped to easy to change. I guess people are changing their minds because the number of responses isn't going up. So, right, the idea is that very few pieces of software can run without ever needing a change. We saw at the beginning of the pandemic that many state systems, and New Jersey is the one we kind of pick on because they actually admitted that, hey, we need COBOL programmers, please come and help us. But many states with systems that ran on, that were old, and maybe hadn't been changed in many years, and maybe they thought never would need to change, needed to change because of the pandemic. I know at least one person that I think he worked on New York's system to provide I think it was nutritional support for schools. And so like, because schools were no longer open, they had to change how all of that worked in order to support, being able to send, get appropriate assistance to those kids that were now at home that would normally be in school and be able to eat a school lunch. And so even code that perfectly works, but it's hard to change, is a liability, right? Now, ideally you have both, right? Ideally you have both. And, some of this runs counter to some of the things that I espouse around like the Agile Manifesto, where it says that working software is the primary measure of progress. And that we value working software over comprehensive documentation. But I think a lot of it has to do with like, I feel confident that I can make the changes if it's easy to change, right? And it goes to this question of how do we keep software soft? The whole idea of hardware versus firmware versus software is that software is easier to change. But if it's hard to change, then we've lost the benefit of having software. Now, what this ends up, one of the things that's tricky here is that there's this dilemma involved, right? So we defined legacy code or scary code as code without tests. And that's one component of it, obviously not the whole thing. But, and so we have this assertion, right, that in order to ensure that our code stays the same, we want to have tests in place, right? So when we change our code, we want to have tests in place. Now, the flip side of that is often to put tests into place, we often have to change the code. And so this is a dilemma, right? Like it's the chicken, the egg. When we change code, we want to have tests, but to get tests, we might have to do some changes. So in order to resolve this, again, we want to do it in as low risk way as possible. So we have this idea of making low risk changes via this set of refactorings called core refactorings. Refactoring is a word that we use a lot in our industry in a lot of different ways. At least I've heard it a lot of different ways. If we go back to Martin Fowler, who was the person who coined the term, or at least popularized the term in its current form, this is how he defined it. And I really like this definition in that it's changing the internal structure without changing the observable behavior. So this isn't just cleaning it up. It isn't enhancing the performance. It is changing the internal structure without changing its observable behavior. It doesn't even talk to intent, right? A lot of times we think of refactoring as making the code better. In fact, performing a refactoring, and I'm using here as a noun, like as a thing that we do to the code, as a specific defined process we do to the code. Oftentimes changing the internal structure, making those changes to the internal structure may make the code worse, may make it less performant, may make it harder to understand. And so refactoring by itself is, again, the intent is good, but again, it's not always ends up that way, right? And so this is, Arlo Belshi took the many, many different refactorings that Martin Fowler cataloged in his book Refactoring, and reduced it down to this core set. And he uses the acronym of CRUD, which we use often to define, database, create, read, update, and delete functions. But in this case, we're referring to how it relates to our code. Specifically, if you look at this, right, what we're doing CRUD on is the names that we have in our code. So for instance, when we create, what we're doing is we're introducing or extracting variables, methods, parameters, and fields, which is taking something that's in the code and giving it a name. When we update, we're renaming those different items. And then when we delete, delete is this inline idea where we take the code that is stored in a variable or that's being assigned to a variable, and we just move it to where the variable is being actually used, or the method, or whatever it is. So I'm going to do a demo of this. It's not really important right now to understand any of this code, but I'm just going to go through and do a couple of these refactorings. So for example, here, if I go, I have r.days, right? So r.days is used a bunch of different places. So maybe what I'd want to do is, hold on. So one of the quirks about this, how I'm broadcasting, is that it doesn't show the overlays. It only shows the specific window. So I have a context menu up. I'm going to introduce a variable. I'm going to replace all 6 occurrences of it. If you see, right, it's taken all of those r.days that it found, and now I now have a variable called days. And so now everywhere here that was r.days is now days. Now, again, this is this idea of creating, right? We're going to create a variable here. And why might we want to do that? Well, what this helps us to do in this particular case is maybe encode some information, right? r.days is pretty descriptive, but maybe we want to add additional understanding that we've gained about what this is, and be like, well, this is actually days rented. And by doing that, we can encode our learning into the code. We don't have to keep it in our head. We can put it into the code where it can be useful to future self as well as other people. Now, that being said, we might be like, oh, well, this isn't super useful. I really just want r.days was sufficiently explanatory, or we need to make some other change. So we might then go and inline it, which basically will delete it in that that variable is now gone. And now everywhere that was days is now r.days again. Let me think. Yeah, so pretty simple stuff that you've probably done to some degree or another. But again, it's that idea that we have these core refactorings, these very simple refactorings that allow us to be able to do these low risk changes. Now, the main reason why these core refactorings are low risk is that, as you saw here, right, I didn't go through and make a bunch of manual changes. I used my tools. I used, in this case, I'm using Writer. Visual Studio has a lot of these built in. If you use Visual Studio with ReSharper, then you have a lot of these things. If you use any of the JetBrains tools, pretty much across all the languages, including even JavaScript, they have pretty good refactoring support in WebStorm. And so, at least for these core refactorings, most languages can at least do some automation, at the very least to help prompt you where you might want to make the changes. So this is part of why they're super beneficial. Okay, so why is this important, right? It's this idea that preserving existing behavior is one of the biggest changes, right? When I talked about that the do payroll checks method, and it really was called do payroll checks, I don't exaggerate. Now, when the person who, in this particular case, we had one person that was kind of responsible for that code, and honestly, nobody else really wanted to touch it because it was such a mess. The problem is that if anybody had to, it felt like this idea of, I need to put on some sort of protective gear. I need to put on a gas mask or hazmat suit or whatever it is. And I need to go in and I need to go and do something that is not very fun. It could also feel like this, where you're like, well, maybe I'll survive, maybe I won't, I don't know. But looking deep into the abyss. And the challenge there is that at least at certain points in my career, early in my career, I only had what's sometimes called edit and pray, right? What you do is you make the change that you think you need to make, you poke around, make sure you didn't break anything. You kind of hope and pray that you didn't break anything, that the thing that you did is the only thing that changed. But my lived experience of this is that you end up feeling like you're drowning. As I got further along in my career, sometimes I tried to work with care, right? So now, like, well, I have some little more skills. I'm a little better at this. I'm not just like changing something and then deploying it into production. Like, I'm actually gonna, I'm gonna have somebody else look at it. These people, they are very careful. Yet I don't know as if this is how I would want to, the situation I want to be in with my code. And so the technique, kind of broadly speaking, that I found to be useful is this idea of covering and modifying. So cover and modify. And what this does is it essentially gives us a safety net. It allows us to be able to, be able to make changes and to be able to catch unintended changes, right? You see these people, they're obviously practicing, but they have safety harnesses on. If they let go, there's probably a net below them. So again, this idea of preserving existing behavior being a hard challenge, like we don't want to take it lightly. So the technique that I have learned that has helped me to better do this cover and modify approach is called using characterization tests. Now, it's a fancy word, and characterization simply means this. Right? So to characterize something is just, what is it, right? What is it now? And the characterizations are a means to protect existing behavior, right? We're not looking for correctness, right? We're not looking for the right way. We're not looking for what you expect. We're looking for what it actually does. Right? So again, it's this unintended consequence of fixing a defect or something where you're like, oh, that's not exactly how I think it should be. It's like, it doesn't really matter what you think it should be. It could be wrong. If you think about it, let's say, for example, that, your payroll software was deducting an extra $100, right, from your paycheck. For some reason, right? Or, and you're like, oh, look, I found the defect that caused that problem, right? You may not want to immediately change that without some sort of communication plan to the employees. You may not want to do that without being, like maybe potentially having other things happen in the system that maybe you don't intend, because I have no idea, like crazy things happen. I don't have it in the slide deck, but there's this Dilbert cartoon where the pointy haired boss asked Dilbert to ask the vendor, like, if, their system ever, deleted their payroll system, and the vendor's like, nobody's actually asked that, but it has happened. So again, we don't want these unintended consequences to happen. So the characterization tests follow this idea of, we want to put the code in a vice so that the things we don't want to change don't change, and the things that we do, we can easily change. If you want another metaphor, it's like lashing down something, right, in order to keep it from moving. So I'm going to emphasize this one more time, and this is maybe emphasizing this too much, but it's really critical that when we're thinking about characterization tests, we do not care if what we're testing is correct. We're defining, for the purposes of our characterization test, correct as what it currently does. We're checking for existing behavior. Now, the benefit of this is that you don't actually have to understand what the code is doing, because you're simply going to, you need to know how it works in terms of like the dependencies and things like that, but you don't necessarily have to understand the logic. That comes later after you have covered it, again, in this idea of the legacy code dilemma. Like, we're trying to get some tests in place so that we can then make additional changes with that safety. So to demonstrate this, I'm going to move back to Writer. And so this is, I'm going to close this. Excuse me. Get a drink here. So I once worked at a company where the first day I started, I was like, I pulled up the code. This was this was back when SourceSafe was still a thing people did. I'm sure there's people who still do it, but like, yeah, anyway, well, we'll leave that alone. Anyway, so I got the code from SourceSafe. I looked at the project. It had a bunch of, or I had the solution. I had a bunch of projects in it. And about half of them were test projects. And so, okay, I was like, awesome. Okay. I went in and I built the project, or built the solution. Building the solution was great. And then I went to run the tests and no tests were showing up. And I'm like, what is going on? So I went into one of the test projects and I tried to build it, and it wouldn't build. I'm like, how is this building if this isn't, what's going on? So it's in the build configuration. The build configuration ignored all the test projects. And so when you built the solution, it did not build the test projects. Most of the projects didn't even build, let alone run or pass. The ones that did compile didn't pass. So it was kind of a mess. So in this situation, right, I'm coming into this video store. Many of you probably know what a video store was at one point in time, the very least from the Captain Marvel movie where she falls into the Blockbuster. But this idea of like, we need to print out a receipt. And this is an example from that I adapted from Martin Fowler's book, which originally came out 20 years ago. So that's why it's relevant. The updated example in the second edition still uses a ticketing system, but it's basically the same thing, just not a video rental store. In this case, I come into here, I'm like, I open this up, I'm like, hey, look, there's a test project, that's awesome. But yeah, so I would say this is actually better than what I had, where I had a bunch of code that wouldn't compile. Like, it gave me hope, and it gave me enough hope that I think at least for a little bit, I tried to fix it. Like, probably should have just deleted them. But in this case, we did have hope. That hope is dashed. There are no tests. So for tonight, what I'm going to demonstrate is approval tests. An approval test is an assertion library. So the difference here is that with any testing framework, we have the framework, we have the assertions, and we have a runner. And a lot of times, in most cases, those three things are bundled together, and that's what we call a unit testing framework. Like if you've used NUnit, NUnit has a runner. Sometimes maybe you've used the runner that's built into Visual Studio or into Writer, or into whatever other IDE you use. I mean, I guess .NET has kind of a runner built in now. If you do .NET Test, at least it outsources to the NUnit test runner. But like there's this runner, there's the framework, which basically allows you to mark things as tests. And then there's assertion library, right? And that's where you do assert that or assert equals or whatever it is you assert, where you actually say, this is the thing that I want to ensure continues to happen. In this case, what we're gonna use, so we're gonna use NUnit. So I'm gonna mark this as a test fixture, and that'll pull in NUnit. And I'm gonna write a test. And this test, since I don't really know what it's gonna test, I'm just gonna call it first test, and that's fine for now. And then I'm gonna pull in approvals. Now, approvals has this idea of using a reporter that reports when there's problems. And I'm gonna use the diff reporter. Okay, so now we do need to know a little bit about the code in that what we're trying to test is this statement method. And so that's pretty much the main thing here. There's a couple helper methods. There's a movie class, a customer class, and a movie rental class. And those just look like basically data. This get customer does some funky stuff. Look up movie does some funky stuff. But statement is the one where this is what we really want to be testing. So I'm going to do.
Question, Mike.
Sure.
So we had a presentation on approvaltest.net last year. Is that what you're talking about with the approval tests and your use reporter?
Yes. So that's the same framework. So approval tests, there's the .NET version, but there's also versions for about at least a half dozen different languages and platforms.
Okay, so we have some background on that. And then the tests that you're starting to write, are those the characterization tests that you're talking about, or are these more unit style tests?
So it's a characterization test, right? So unit tests is one of those things that we could go down a rabbit hole and think about how to define what a unit test is and what a unit is. And people have a lot of opinions on it. I have opinions on it, but for the purposes of tonight, I'm using NUnit as a testing framework. I'm using approval tests as the approvals as the assertion library, basically to check my output, right?
Okay.
So in this case, right, I'm calling statement. Again, if some of you have some familiar with approvals, I'm just going to verify the result. And I'm going to go ahead and run this. Now, maybe throw in the chat, like if in a typical unit test, we have like, or in any sort of test really, because like given, when, then, arrange, act, assert, they're all basically the same thing. This idea of we have kind of these three phases to our tests, where we do setup, where we do the thing, and then we check to see if it's correct. And so in this case, we have this idea of I do some setup in that I do a new rental info. I do the thing by calling statement. The thing that is missing here when we do approvals is that is we don't have what it is that we want to do. And again, forgive me if we're familiar with this. We will get to some additional things after the characterization tests. But if I come over here, what using the diff reporter does is it will allow me to look at what actually I'm trying to verify. In this case, it's this. This is what I got back when I called statement. And so again, in the spirit of characterization tests, I go, that's what I got. And right here, we see that that's what we received. Over here is what we have approved. And notice we haven't approved anything. That's because we haven't run this test before. And so approvals creates this file for me and says, you ran this thing. This is what I received. I don't have anything approved for this. And again, in order to, again, in that, because I don't care what it is that it's doing, whatever it's doing right now is the right thing, right? If you think about it, especially now, if you have a video store and it's running code still, that it's been running that code for 20 years, and whatever it's doing, whatever it has been doing, is the thing that you expect it to do. If you see here, like if it was giving extra frequent enter points, you don't want it to stop giving those, because then you're going to have pissed off customers because they're like, I expected to get 20 frequent enter points and now I'm only getting 10 or whatever. So we don't want to make changes that are unexpected. And so I've approved. So what I did is I copied it up basically all over. I've saved it. I'm going to close that. I will come back to Writer. And I'm going to now run this again. And now it should pass, right? Because whatever was happening is still happening. But we see that it is not super happy. It's like, huh, well, that's interesting. We now look that we have a different thing happening based off of, I don't know, I called the statement again. I called the exact same thing. So this is a problem, right? Let me call it again. Okay, so this time it passed. So this is curious, right? It gave me this result. The second time I ran it. So there seems to, and then the third time I ran it, it got the same thing as the first time and it approved. Now, at this point, I don't necessarily want to put this into my deployment pipeline because I have no confidence. It seems like every other time it's not working. So let's go back to our slides. Okay, so what we want to do at this point is we want to find or introduce seams, right? So obviously there's something non-deterministic going on in our code, and that makes testing difficult, right? Ideally, we are testing things that are deterministic where basically they'll get the same result that every time I run it, it will either pass or fail based off whether it's actually working. So what sometimes when we're dealing with code, production code that, is scary and nobody wants to touch. In order to tame this, we want to find a seam or create a seam where we can alter the behavior of the program without editing in that place. So the easiest place to make a seam or to have a seam, and there are a bunch of different ways you could do this, right? But the most common one, at least within code, is at a method boundary, right? This, like, when I call a method with certain parameters, I can change which parameters I pass in, which changes what happens within my code, right? Without actually editing the code, right? I haven't hard coded those values that I'm passing into the method, inside the method, right? And again, this is when I'm trying to test a method. So what we're going to do first is we're going to use a technique called peeling, right? So occasionally these non-deterministic bits of code are at the edges of our code. And what we can do here is we can peel those non-deterministic parts off, and then we can just write a test on the deterministic, the green, the happy part. And that way we don't have to worry about those non-deterministic bits, at least for this first pass, right? So we're going to go ahead and now peel this. Okay, so as we saw, like, calling statement was no bueno. Now, if we look here again, there's this get current customer method call here at the beginning, and that gets the customer. If I go to that, and so in a real system, maybe this is a database call, right? This is going to go actually get some data from somewhere. In our case, again, to mock this out, to fake it, get current customer basically just randomly gets one of two customers and returns them. And so sometimes it's going to get one, sometimes it's going to get the other, and that's why we have our problems. You notice here that the movies that it gets back are different for each of the two customers. So this is problematic, right? Because with this randomness in our code, it's not deterministic. So in order to peel this off, close that too. What I'm going to do is I'm going to use my core refactorings here, one of which was extract method. So what I'm going to do is take everything except for that get current customer in this method. So from line 11 down here to 58. I'm going to use my tools here. I'm going to do extract method, which you can only kind of see. I'm going to call it statement. And basically this method is going to take in a customer, and that's it. So writer did some magic right here. If we scroll back up here, we now have our statement, which is the statement that we had before. It calls get current state customer. And then it calls this new statement with that customer. So now we have this private method called statement that takes in a customer. And so now, at least we hope that most of this is going to be, that this is going to be deterministic. So I'm going to make this public so that we can call it. And I am going to, I think it's this one. I'm going to basically take this customer and I'm going to pass them in here. Okay, so instead of calling the statement with no parameters, I'm now going to call the statement that has a customer. This customer has a list of movie rentals. All of this, again, we don't really care. We got a customer. We're going to pass them in, and we will now run our test. Now, if I pick the right customer, this will pass. It failed, which is fine. Again, now that we know that it's deterministic, we know a little bit more about the code. We can say, okay, well, we approved the one that had cars 2 and latest hit release, but really we want to approve this guy. So I'm going to say what it currently does, again, is what I want it to continue doing. And now if I run my test again, come on. It should now pass. And if I run it again, it should continue to pass. And basically it should presumably always pass now, right? Because again, that part that was non-deterministic, potentially hitting a database, might have been hitting a third-party service, might have been hitting a service within our own infrastructure, right? Doing an HTTP call or whatever. Whatever it was doing, we want to kind of slice off that part that's interacting with the outside world and basically have this deterministic bit that we can more easily test. Okay. Excellent. Okay, so sometimes though, sometimes we have a dependency that's somewhere in the middle of our code, right? So we have this like part that's calling out to some third-party service or a database or something, and it's in the middle of the code. Depending upon our situation, right, we could kind of take this top part, we could take the top part and we could chunk that up and create a method there, or chunk up the bottom part and get a method there. But ideally, you know, that's a little more change, and maybe that's appropriate. But what we could also do is a technique called slice, and that's where we're going to slice out that dependency. We're going to inject it into the middle of our code using parameter injection, which some of you may be familiar with. But let's see. Let's go back to the code. So, right, so it's this idea of, at this point, calling statement, I can, remember, I'm gonna run coverage, right? So we see that, actually, no, we're not gonna worry about coverage for what we're doing tonight. Sorry, so if we come into this statement, we can get to this part where we say, oh, look, it's going to look up a movie. And let's say, for example, that we don't have all the movies that we want to be able to test in our production database, or we just don't want to have to hit our production database in order to look up a movie. And so we don't necessarily want that method here in the middle of our code. Again, if you look here in the code, the example code, we just have it in memory dictionary, right? It'd be easy to add something to this. But again, for demonstration's sake, we could say that this was a third-party thing, whether that's, again, a database, another service, an HTTP service, whatever it is that we're trying to get to. So what I want to do here is, what I'm going to do is I am going to extract class. And I'm sorry you can't see all of what I'm doing here using Writer, but just a couple things. And so I'm going to extract a class called movies. And basically, I'm extracting this method. I'm moving this method to another class. So I'll go up here to the top. We now have a class called movies. It has our lookup movie method. You can see it's exactly the same as it was before. And now if we come in here to the class, we have a field movies that is a new movie, movies. And then here in line in our code, it does movies.lookupMovie, right? Which is pretty good. But we still have this movies that's inside our rental info class. And so what we'd like to do is take movies, and I'm going to introduce parameter. That's right. And that is fine. Okay, so by introducing parameter on underscore movies and renaming it to movies, I can now, in my statement, pass in movies. Now, here in my kind of wrapper for statement, again, maybe this is not where I want the code to end up, but at least for now, what I can do is, this is the interaction with the real database. And that's going to get passed in. But for the purposes of my test, now that I have this method where I can pass into movies, I can go back over to my tests, and it's obviously, I can't do this. But what I can do, hold on. So I can just create a new movies as a first step, right? And that will get me running again and passing, right? So now I've just taken the real movies and instantiated it here, but that does not, it doesn't necessarily give me control. So the additional step that I would want to do is I would want to introduce an interface. So I'm going to extract an interface. So I now have an iMovies interface that you have to implement lookup movie. And now what I can do is I can, I'm gonna second oven this a little bit. Right, so now instead of using the real movies, I can now do my test movies database. Why is it? Oh, because in here, I'm taking a concrete movies. So if I change this to iMovies, this is not an advertisement for Apple. Just creating interfaces here. So we have iMovies, and now we could send in a test movies DB. This allows me to then add as many different, right? I can add if I'm trying to test, I can add a very, very long name, maybe longer than any of the things that are in our production database, but now I can add that here in our test. So in case we do hit that, we can figure out what the limits are. We could do very short names. We could do things with weird characters. We could also potentially do different types of movies. Here we have regular, children's, new. We might have different types of movies that come out. And again, this gives us control over that in our testing environment. If we maybe need to add additional movies that aren't in our current active database, but maybe were in the past or will be in the future, and we want to make sure that all the code paths are hit. So again, we haven't really looked at the code itself that much. We've kind of stayed at the edges of it in that, we peeled off the get current customer, and then we found this kind of problematic lookup movie and pulled that out by slicing it out and injecting it as a dependency. So by using those techniques, I don't even need to really understand all of the things that it's doing in here. I don't even need to, in this particular case, at this point in time, do code. And then what I would probably do at this point was I would run some coverage and then add additional tests until the code was in a place that was fully covered. And then I'd go ahead and make whatever change I need to make. But that's not what we're talking about today. So again, just this idea of like, I want to cover before I modify. I want to use my core refactorings ahead of making any substantial, like using the core refactorings to make changes to the code safely, and then so that I can get tests in place. And then once I have the tests in place, then I have a lot more confidence that I can make the changes that I need to make. Okay, so hopefully these are some very, I don't know, like on one level, they're like super basic techniques. On another level, they are sophisticated techniques. But legacy code, right? I made this a statement that code without tests is scary production code that nobody wants to touch. Now, hopefully, as a result of giving you some of these tools and techniques, we can eliminate that nobody, and hopefully you will want to touch the legacy code. You will now have the tools in place so that you can go in and make the changes to that scary code that other people on your team are afraid of. You don't want to be the person that is on the other side that's hoarding the code and not allowing other people to touch the code. Sometimes people think that that gives you job security. It's not necessarily a happy thing, but in that case of the person who was kind of hoarding the due payroll checks, eventually we were able to get that under test, start to make some changes, help to pull it apart, factor it into a better place. I didn't know this at the time, but eventually that guy got let go basically because like, I don't know, it's a whole story, but like, it's very difficult, like to learn from other people if you're not being open with your code. So hopefully this will give you some techniques. Hopefully you don't use it to get your coworkers fired, because that's not a good thing. But at the very least, you want to get a broader view of the code. So one last comment on legacy code. At that same conference where I talked to Michael Feathers a little bit, Jessica Kerr made this statement, which I tweeted, and was that she said, when I hear legacy system, I hear useful, and I don't want to work on a system that is useful. Sometimes we think it's fun to work on greenfield projects where we're just like making stuff like that's brand new, but nobody's using that yet. And hopefully someday it'll be useful. But once we're working on something that is in production that people are using, that's really generating value for people. And I personally agree with the sentiment that it's a lot of fun to work on code that is useful to people and that is actually getting used in the world. So with that, in the same spirit, right, as we're trying to make changes to code, don't be afraid to make the hard change in order to make the change actually easier. Because sometimes getting code in a position to make changes can be difficult, but it can be very rewarding. So with that, I have some resources, and if you want, I'll share these slides out in the meetup comments. With that, I guess we'll go to questions if there are any. Thank you, everybody.
Thank you, Mike.
So, Mike, I had a question about
Sure.
the automated refactoring. So, first of all, I wanted to congratulate you on a great presentation. Thank you. In a discussion that I actually had this weekend about automated refactorings, both with ReSharper and Writer, the discussion turned to the safety of those, whether you have tests or not. And the comment was made that especially these core refactorings are very, very safe, incredibly safe, as long as you keep in mind the possible bugs or limitations of those refactorings. And so my question to you would be, what awareness do you have? What tips do you have for us about possible pitfalls of automated refactorings that you've seen?
Sure. So I mean, I've definitely seen ReSharper and Writer do things that I didn't expect occasionally. I think to that point, your tools aren't always going to be right, but keeping to those core refactorings, and part of it is having familiarity with your tools, right? Knowing which situations that it's going to do well in and which situations it may just like do something funky on. And so part of my advice to people, if they don't know their refactoring super well, is do some just code exercises. There's plenty of code exercises out there. I mean, I have some that I prefer, but like, you know, there's subreddits, there's Code Wars, there's Exorcism, there's the Kata catalog. There's like a bunch of different places where you can go to find exercises, or even just find some, there's a lot of actually refactoring exercises you can do out there. Emily, I think she pronounces Bach, but she has a bunch of refactoring exercises that are awesome out there. Also, this particular exercise that I did tonight, it's at that starting point that I showed today, and it's on GitHub. Like, practice with it. You know, like try some of these core refactorings, like try extracting method, try extracting, introducing parameter, see what it does in different situations. And because there are definitely ones that I'm more comfortable with and more like, I am like 99.999% confident that this is going to do what I expect to do. And then some of them I'm like, well, let's see what happens. And maybe I'll have to make sure I commit before I do this one, because I might have to roll back or get reset hard. I don't know if that helps at all, but I have a lot of confidence in the tools that I use on a frequent basis.
Yeah, thank you. That was very helpful.
Like that, like there's like the extract method or extract object, there's like move method, like you can move methods between objects. Like some of those, like you have to have things set up very specifically in terms of like whether it's static or not static, and like which fields are included and things like that, where it can get tricky. I, again, try to avoid those when I'm not under test yet, if I can, or at least very minimally use them. Any other questions? I don't think I got any via Slido. Okay, well, I will hang out a little bit afterwards. I don't know how long they'll keep this open afterwards, but if anybody has any questions, then happy to hang out. I'm also, you're welcome to connect with me on Twitter or on LinkedIn. Again, my GitHub there's MD Clement. If you go there, if you look for video store refactoring, you'll find this repository. As a couple quick plugs, I do run the Software Crafters Atlanta group. I'm also been one of the silver linings, I guess, of the pandemic is that I've been able to attend a bunch of the Utah Software Craftsmanship Group meetings that are happening. You can go to utahsc.org and find that. But you could also come and join our Atlanta group if you'd like. So once I moved here about 5 years ago, I started up a group here. And the other thing is that John Turner, whom many of you probably know as a previous presenter here, he and I are facilitating a workshop on test-driven development next Thursday. We're actually doing a pair of them. Again, I'll put those in the meetup. If you'd like to register, we are charging a nominal $5 for those, basically just to, prevent drive-by signups. And so we will be raffling off a book as part of it. So again, we're not looking to make any money on it. We really want to give back to the community.
Roughly what, $5 for 3 hours, if I remember right?
Yeah, so it's a 3-hour workshop. We're just charging $5. So it's yeah, I've charged much more for this type of thing in the past, but we just really want to help the community better. It's just an intro to TDD. If you've done a lot of test-driven development, it's not really for you, but maybe something that you can point friends that are earlier on their TDD journey to. Anyway, that's it. Thanks.
Okay, well, thank you very much, Mike. That's a great presentation. I'm going to go ahead and share my screen again.
Oh, should I stop the stream at this point, or do we want to have you? Is there something we want you to share on the stream?
I don't believe there is.
Okay. Then goodbye to those